welcome to True Projects. In this video, we are going to explain about a project titled A Novel Machine Learning Approach for Android Malware Detection based on the coexistence of features. Malware detection entails the utilization of variety of techniques and the tools to not only recognize but also thwart, notify and counteract the menacing presence of malware threat. Fundamental methodologies encompass the identification and the confinement of familiar pearls, including the signature-based detection, checksumming, and the establishment of application allow list. Amidst this landscape, highlighted the attention is drawn to the mounting apprehension concerning the device security and individual privacy, in consequence of the multifaceted capability preferred by the smartphone and the proliferating range of user activities they facilitate, particularly in the Android domain, which remains the prominent operating system with an expensive user base exceeding of 2.5 billion individuals across the 190 countries. Vulnerabilities are exacerbated due to its open source nature. This exposed a fertile ground for malicious actors to perpetrate the attacks and the fashion Android malware app bearing the grave implications. We introduce an innovative learning strategy to effectively detect the Android malware centered around the synergy of static features. Our approach posts the Android malware exhibits the aberrant co-occurrence of permission and the APIs, distinguishing itself from the beginner through the curation of an original dataset that encompasses the various levels of combined permission and the API calls. We harnessed the potent frequent pattern growth algorithm to extract the paramount coexisting attribute, demonstrating its superiority over the existing model. Our approach excels in the performance, showcasing the remarkable accuracy through the application of the neural network algorithm. This pivotal role of the coexisting permission features, particularly at the second combination level, emerged as a key driver in achieving this highlighted efficacy. These are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7 on Jupyter Notebook. Hardware requirements are operating system as Windows or Linux, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this, we need to import the necessary Python libraries such as NumPy, Pandas, C1, Matplotlib, sklearn, Flask. And the second step is exploring the dataset. Through the exploration of the dataset to comprehend its structure, attribute, and the data distribution, we need to load and inspect the dataset using the libraries like Pandas. And the third one is data processing. Process the data to handle the missing values, outlier, and the noise. Conduct the necessary data cleaning, normalization, and the transformation to ensure the data set is suitable for the analysis. And the next one is visualization using Seaborn and the Matplotlib. Utilize the Seaborn and Matplotlib to create the meaningful visualization such as histogram, scatter plot, and the correlation matrices. And the next one is label processing. Convert the categorical label into the numerical representation using the technique like off-label encoding. Ensure that labels are appropriately formatted for the model training. And the next step is feature selection. Select the relevant features for the model training. Employ the techniques such as feature importance score from the ensemble model or the statistical test to identify the influential attributes that contribute to the Android malware detection. And the next step is data splitting to the training and the testing. Divide the pre-processed data set into the training and the testing subset using the functions like train, test, split from the scalar. And the next step is building the model. Here various machine learning models are built. The first one is logistic regression. It is a simple yet effective classification algorithm suitable for the binary outcome like malware detection. In our project, it serves as a baseline model to establish a foundational understanding of the dataset dynamics. Logistic regression estimates the probability of a sample belonging to a certain class, making it interpretable and insightful for the feature important analysis. And the second one is KNN. It stands for K nearest neighbor, is a distance-based classification method that assigns the label based on the class of the nearest neighbor in the feature space. In our project, KNN can capture the local pattern within the coexisting features, contributing to identifying the malware cluster. And the third one is SPM. It stands for Support Vector Mission, is a powerful classifier that identifies an optimal hyperplane to separate the different class. For our malware detection task, SPM can effectively handle the complex decision boundary and capture the intricate relationship among the coexisting features. The selection of kernel function influences the SPM ability to model the data. And the next one is decision tree. Decision tree partition the feature space into the segment based on the attribute threshold, making the classification decision at each leaf node. In our project, decision tree can offer the insight into the most relevant coexisting feature for distinguishing the malware instance. Decision tree can be prone to overfitting, so technique like pruning and ensemble method be enhance the robustness. And the next one is random forest. It is an ensemble decision tree that reduces the overfitting by aggregating the multiple modal prediction. It effectively handles the noise and the non-linear relationship in our malware detection task. And the next one is neural network. It's a deep learning model that can capture the complex pattern in the high dimensional data, and in our project, NN can reveal the intricate interdependency among the coexisting features, potentially uncovering the subtle malware detection. And the next step is user gives the input. Develop a flash web application that allows the user to input the relevant data for the malware detection. And the next step is the given input is pre-processed for prediction. Here the pre-process the user input data similarly to the training data, applying the same data processing step to ensure the consistency. And the next step is trained model is used for the prediction. Utilize the trained machine learning model to predict whether the input data indicate the presence of Android malware. And the next one is of final outcome is displayed. Present the prediction outcome to the user through the Flash web interface, communicate the result and the potentiality to provide the information based on the prediction. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. And the dataset folder containing of the datasets that we used in this project, and the sample folder containing of the various files, APK files that will be used for testing the performance of the model, and the static folder containing of the folders like CSS, images, JavaScript, models and upload folders within it. And the template folder containing of HTML documents, it typically include of form, index, sign in, sign up and the users pages within it. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operation, such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the model is a model file contained of the algorithm information, and is loaded into the project code during the runtime to utilize the trained model for the various tasks such as making the prediction on the new data. And the notebook is an IPYNB file which contains the combination of code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this it will change the current directory to the code folder path. And then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues. And then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here we can see the title of the project and content of sign up button. Click on the sign up button, it will redirect you to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of username and password, and we need to fill those details. And then click on the sign in button. Here it will redirect to the index file containing of the choose file and predict button. Here we need to click on the choose file button. I'm selecting one APK file and then click on the open button. And then click on the predict button. Here it will predict it as of the class benzene and the modal accuracy is 92.26%. And then by clicking the black button and the refresh button, here we can upload the another file too. By clicking on the choose file button, I am selecting one file and then click on the open button and then click on the predict button. Here it will predict it as of the class as malware and the modal accuracy is 92.26%. In this way we can classify the malware using the APK files. And in conclusion, the proposed approach using the featured coexistence and the effective method to detect the Android malware. We created the dataset of the coexisted features, which are coexisted permissions feature only, coexisted API features, and the coexisted permissions and the API features. The experiment have shown the random forest decision tree, logistic regression, SVM, KNN, and NN algorithms achieved the best accuracy at level 2 of the coexistence using the permission API coexistence in the CIC Malware 2020 dataset. The proposed approach outperforms the state-of-art model and achieved the best accuracy using the Dribane and the Malignum dataset respectively.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.